So we didn't finish to talk about how to build out the database. So that's finished earlier your example. So I believe you try to read from that. So right, the most important thing when you have your from city, we need to find if they are already there. Otherwise, we need to make the new node. So then we make the new node for the from city. So then we will push that to the vector. But one thing is, after you get that right, the most important thing is you also need to get the true city index. So that's why we can add into the neighbor link. So that's why I continue after I got my from city node is I. So then I continue with to find the true city index. So the same thing, if we find the true city, the index will be I. Otherwise, I need to add the new one. So then we have two cities save the index into the I2 node. So after you have that, the most important thing, don't forget, we want to have the bi-direction link. So then for the from city node, the neighbor, that's the list, right? So we still can use the pushback, but we only push back the index for the two city. So then for the two city node from the database, the same thing, I need to find the neighbors list. So I push back my from city index. But after you're done, you see you just run, you input file process and finish. So we didn't know what we restore, right? So that's why here I also show you how you will print out all the information from your database. So then we display all the nodes from the index and the city name. So you can really see you have the database ready. So we have the database in the vector. So we're using the I equal to 0, I less than the size. So then you just display the city information, the from city information. So then don't forget, we need to iterate through our list. So I will display the neighbor index and the city name. So how to display the city name, right? So you have the index, just using the name. So then the same thing, after here we got the neighbors to traverse the list. So then you can get this it from the beginning to the end. But one thing is here, your begin to the end, this it, don't forget you need to dereference. So after you dereference, actually they just an integer. So that's the index from the database. So I dot name, I can print the neighbor's name. So if you finish this one, right? So then you see if you run the program. Then we can display all the information from the database. So then you will see here. Oh, that's a lot. So then actually just you see from index, the first one is Eureka. So this Eureka, they have four different neighbor they can go. So of course, you see they have all of that. Great, so after we build out the database, now we can start working on what we want to do. So we're back to our PowerPoint file. So the next topic, we will talk about how should we iterate over a graph. But when we say iterating over a graph, that's me. For example, now you are, people sometimes in movie are crazy. They got in San Francisco airport. They don't know their destination. They just want to randomly to buy a ticket. So then actually when you got in San Francisco, right, the first thing you need to know where San Francisco can go. So this one is our first approach. We say iterating through the graph. From one star city, I want to list all the city I can travel to. So when you have stuff from San Francisco, right, can you go to Denver? Yeah, you can. Can you go to Washington? Yeah, you can. Just maybe you don't have direct flight. You maybe can go this way to Chicago, go to Washington. Or you can go to Denver, go to Los Angeles, then go to Washington. But no matter what, that's all the connect to show you can go to somewhere. So this one, when we talk about the next topic, when we say iterating over a graph, That means you found a 1-star city. You will see where you can reach. So kind of we say we list all the possible route. So that's what we want to do. So that's why when we have a star city, then you need to find where this star city, right? So then you have two approach to find all the possible routes. That means find all the reachable node from that star city. We have the BFS that we will introduce in this video. So then the next one we will do the dip, the DFS. That means the depth first search. So we just quickly to see the BFS and DFS search, what that mean. So you can go to the picture 2 again. So we just say, for example, that's San Francisco, right? That's our star city. So actually what we need to do, where we can go is, we just need to go over all my neighbor list. So after I have one neighbor, right? So I just from this neighbor, go to their neighbor one by one. So that's why you go to this Denver. So then from Denver, you will go to all their neighbor. And all their neighbor will continue. So that's why you can see from this one, the BFS search, we just to go wide first. So then I continue to expand until I reach the dead end. Until the neighbor, they don't have any neighbor, we finish. But if you also see by this way, right, sometimes you maybe count your neighbor more than one time. Because you can see here, I can go to Chicago. But when I reach Denver, Denver also go to Chicago. So that's why on the other hand, we also need to mark if this city are already being visited, I should not visit that again. And also the other thing, when we say you find your neighbor first, right? So neighbor find their neighbor. Then you will find that that's kind of is a recursive step we need to do. Because from one city, I go over all my neighbor. So then from my neighbor, I go over their neighbor. So it's kind of the recursion step. So then we'll also show you we have other different way to do the recursion step. So that's our BFS search first. So since earlier we said that the BFS search first, right? So then actually we need to add one more information to our node chart. This one is earlier we say. Sometimes your node or your neighbor node, they being visited already. So here I should avoid the duplication to visit the same city. So that's why in our node struct, did you remember earlier we say, sometimes we have tracking variable. So now I need to add tracking variable in there. So that's mean, is this node being visited or not? So that's why here, right, so then we will see the second thing after we add the bool is visit into our node struct. Then we also think about, did you remember earlier we say we need to go to the neighbor, then neighbor's neighbor. So then actually this kind of is a recursive solution, right? So this time we do the recursion function a little different way. Before we always call a function again, right? But now we were using a different way is we're using a queue to processing our recursion step. So that means here when we see a neighbor is reachable, I just push into my queue. So once I push into my queue, I add all the reachable neighbor into the queue. So once the queue not empty, I just continue to pop. So I'm using that to process one by one. So then that's a recursion solution. For other neighbor, we are working on the neighbor of the one of the star node neighbor. So then you will see here before we start showing you the pseudocode, I just want to show you the first thing. Our struct become like this. We still have name, we still have the neighbor as the index, but now we add the bool attribute. So now let me show you our pseudocode or our concept. How should we do that? So the first thing you will see here, that's our BFS searching function. So this function, you see, I need to have the star node, then passing me the vector, database vector. So then your return type actually is what? The return type actually is another queue. So here, be careful, we have two different queues. One queue is the return. Because you give me the San Francisco city, I need to show you all the city you can reach to, right? So that's why we push all the possible city into a queue. So that's our result queue. So at the end, just return the result. But inside here, we have another thing is we have a to-do queue. So this to-do queue that's how we will do the recursion function. So the recursion function for any node I need to consider, I put that into the queue. So as long as the queue is not empty, I will continue to processing and pop out the queue to reach their neighbor. So we will see how to do that. So here just the function prototype and what we need to return. Right, so the first thing, you need to create an empty result queue. So this result queue is later at the end we need to return. So this result queue, of course, they are empty at the beginning. So then you need to have another queue. This queue, that's called they are to-do queue. So this to-do queue is all the considered nodes I need to push into there. So according to that, each node, I will find their list, find their neighbor, and push to the queue again. So then before we start, the first thing, you need to initialize every node in the database. Set the isVisit equal to false. Okay, so that's why we call that the tracking variable. Tracking variable is a little different than our name and our neighbor. Your string name for the node or your neighbors in the list, they never been changed. That's when we build the database we have. But those tracking value, a lot of time before we start working on our database, we need to initialize the value equal to the default value. So that's why before we start, when we pass in the database to our BFS search function, we need to make all the bool isVisited equal to false. So that's why we know each node, do they visit or not. Okay, so then we continue to see the pseudocode. After you initialize each node in the database equal to not visit, right? Okay, so that's star. So this one we will start kind of our recursion function, recursive step, but we have our prepare work. So after you have your origin node passing, right? So that's our starting node. So when you see that starting node, of course, be careful, they are passing by index. So that's easier for us to access. So you just need to go to the database using the index to set the isVisited equal to true, because we start processing this one now. So then after you have this node, right? So good. So that's what we want to do. This one is the start node. We need to push that into the result queue. Then you need to have your start node also push into the to-do queue. So after you've done that, you should know your beginning actually is yourself for the result queue, the first one. So then you will have your start node push to the to-do list. So the to-do list actually is queue, right? Okay, so that's why here, pay attention on the blue line here. That's our recursion step. So as long as the to-do queue is not empty, we just need to continue, repeat to do those things. So I don't have enough time. So this video will finish soon. So I will talk